The next method we're going to look at is called AND. If we have time, we might look at any and all as well, but first we're just going to look at AND. And AND is sort of like a Boolean for options, sort of. So it's sort of that. And what you do is, I'll show you the signature first. So AND, here it is. So it says right here, returns none if the option is none, otherwise it returns opt B. And that's just the name they gave it for this thing that you put in. So if you look at the signature, it's really simple. It just matches self, and if it's sum, then it passes it on. Doesn't care what kind of sum, and if it's none, it is a none. So it's just a method on an option, and you go and, do some stuff, and then you pass it on, and what'll happen is you'll get, at the end, you'll get either, a sum or a none. And if you have none, then it'll like short circuit, it'll cut everything off. And, it's kind of, and that's why I say it's like a Boolean, because if you look at Boolean logic, you have, let's say, 1 equals true, then let 2 equals false, and then let 3 equals false, or true, I mean, and then let 4 equals true. So we have these 4 Booleans, and then, one false makes everything false. So if you have, let's see, if you have 1 and 3, right? So you have a true and a true, that together, a true and a true is going to be true. But the moment you put 1 false into there, so you can see there it prints out true. Whereas the moment you put 1 false in there, you have a 1, 2, 3, and 4. It's going to print false because that's just the way Booleans work. Once you have a false, then everything becomes false. And that is basically the way AND works. And I have an example here that's pretty long to type. So I will just paste in the first part here. So here's our main function. And you can see we have this these 3 vecs, and these are like the results of some option get that we did. And you can see this one has sum, none, sum, none. This one's got none, sum. This one's a whole bunch of sums followed by none. And then we're going to work through these vecs. And so what we'll do is for I in 0 up to first try dot length. So we're going to go 0, 1, 2, 3 like that, and go through every item, and then we'll say we'll print, and we'll do this. So we'll have first try, and then we're going to we can index here because we're passing on options. We're not trying to unwrap them or anything. So, and we know with this length that we are definitely not going to go over the bounds. So first try dot I, and then this is where we use and so we do second try I, and then let's see, and third try I. So what we are doing, you can see we're looking at the first item of every vec, and we're trying to see if we have sums all the way through or nones all the way through. So we're going to look at index 0 of here. That's going to be a sum, then it's going to be a none, then it's going to be a sum, and we're passing it on, and that's why we're using and we're going to see if we get a sum at the end or if we get a none at the end. And the result is none, none, sum, none. And you can see, it's very Boolean here. So you have sum, none. So that's why we have a none for index 0. Index 1, that's a none. So right away, that one's done. That's going to be a none. Index 2, you have sum, you pass it on. We got 3 sums. So it passes on this last value. And so you can see it's and it's kind of like a basically, yeah, it looks at all the options, and then once you get a none, then that's the end. And it's a good way to pass these on and see if you keep on getting sums or not.